you should have a DHCP server. It's not you should. Normally you will have and DNS server. You don't need a server actually. You can run this DHCP and DNS anywhere. Maybe your access point can also be a DHCP, right? Okay, so DHCP stands for Dynamic Host Configuration Protocol. So it follows the client-server architecture. So you have one server that will be in control of IP addresses. We call a pool of IP addresses, and you have DHCP clients. So this is just the process of obtaining IP addresses. So a client can obtain IP addresses in two ways, right? You know that, statically or dynamically. Now this is the dynamic part. Static means you will always manually enter an IP address. It will always have that IP address. But normal clients, when they boot, this is the DHCP process. They say, okay, when the DHCP client, when the client boots, they send a broadcast. Okay, a DHCP request is a broadcast. So that broadcast will hit everyone and ask, are you a DHCP server? Right? So everyone will drop it except the DHCP server will reply back. It's a three-way process. Right? DORA, which is discover, offer, request, acknowledgement. So first a broadcast will be sent that will discover the DHCP server. The DHCP server will offer that, okay, I am a DHCP server, what do you want? And the client will request, I need an IP address, okay, and other things, and the DHCP server will acknowledge it acknowledge back with the IP address and the gateway and DNS IP address and all. So it's not just the IP address, it's DHCP server comes with the default gateway, DNS server and all these things. Okay, subnet mask. So that's a three-way process. So when you configure a DHCP server, you basically have a scope. That means what's the range of IP addresses. Now you can have more than one scope. Like I think the next lesson you will study subnetting. You will know that. Like how many networks, and each network how much scope, how many IP addresses. Right? You can say 1 to 100, 1 to 200, or 1 to 50. You can reserve something. Okay, that's the scope. The pool size. Okay. The other thing is lease, that is how long the IP address will be entitled to the DHCP client. Okay, lease duration. The options, like what will be the DNS server address and other things. And reservations, you can reserve some IP addresses, fix it. Like whenever a particular client comes, give this IP address. Okay. Normally whenever a client comes, it just gives whichever IP address is free in the pool. But you can reserve an IP address through DHCP itself. Whenever this particular MAC address comes, client comes, give this specific IP address. Exclude means don't include in the pool. So you will use these IP address for manual, static assignments to something, like printers and all. Static allocation. So actually there are three things. Statically you can allocate automatically or dynamically. This is DHCP, dynamic allocation. Static, you manually go and put an IP address. What is automatic? Actually, there's three ways a computer can get IP address. Static, you manually go and put an IP address, mask and gateway. Dynamic, so this covers a DHCP. DHCP gives an IP address. Automatic. Automatic happens when you have no static IP address and you do the DHCP discover, no DHCP servers are in the network, nobody has offered, then the computer will come up with it. We saw that, right? APIPA, automatic IP configuration range. So it will automatically come up with the IP address 169.254 range. That's automatic. It literally means computer has no IP address. So there is lab, you can go to the control panel and all. portion here.
60. Yeah, but you know that's the point.
We already tried these things, right?
Yes.
It's a very straightforward process. There is no room for any confusion. There is it's nothing complicated. Very simple and straightforward process. And another important process is DNS, okay, domain name system or domain name server. This is also a straightforward process, but it is both the DHCP and DNS, they are very critical, crucial components in a network. It should be well protected. Okay, in a LAN it's fine, but in a WAN environment, if say somebody hacks the DNS server, then they have most control over it. Okay, so you will understand because DNS basically means what it does. It resolves name to IP address or IP address to name. Okay, so you have two way of resolution. You give a name, it will give an equivalent of IP address, or you give an IP address, it will give an equivalent of name. But normal thing that happens is this one, name to IP address. That is called forward lookup. Okay, forward lookup. Let's say I give a name Google, it gives me the IP address of Google. I give a name Facebook, it gives the IP address of Facebook. So all these names, they have a corresponding IP address on the internet as well as on the LAN. WAN as well as LAN. Okay. LAN it can change, but WAN will be permanent. The IP address of Google will be permanent. It depends on the region. So when you buy a domain name, there will be an IP address associated with it. Like you are buying a website, there will be an IP address associated with it. Okay, so that's what the DNS server does. Okay, so now you can understand there is a global DNS server on the internet. So all the names and IP addresses equivalencies are registered in there. So when you buy a website, you are basically registering your name versus your IP address in there. So very first time if somebody is accessing the website, very first time. Then that name, so you're typing like lawrence.com. Okay, so it goes to the corresponding IP address will be fetched, and all the routers will use the IP address for routing. So we can't use, now why we are using it? Because we can't use names for routing. Okay, because our IP tables and routing maps and all these protocols, they use IP addresses, not names internally for their working. So you have to convert names to IP addresses. But we don't use IP addresses, we use names. Right? We can't remember IP addresses of all the websites, right? So we use names. So that's the point. And so basically DNS has records. There are different types of records. The basic form of record is a record. Okay, if you go to a DNS server is basically a database, right? It's like a database. So this database has many types of records. Okay, the most common is a record, which is a name to an IP address, a domain name, a host name. Okay, a host name and an IP address. It's network and all. And you have C name, which is Canonical name, which is alias name. A website can also have a nickname, an alias name. You can also give a nickname, like a very long name, you can shorten it. Okay. You see this. This is a very long name, right? You can shorten like this. That's C name. You can have MX record that basically points to mail servers, email servers specifically. Yeah, like if it is a normal client which doesn't show what kind of client it is, what kind of host it is. Okay, it's a normal computer, whether it may be a whatever computer, then it's just an A record. If you have a computer which is specifically a mail exchange computer or a mail server, then that is an MX record. So the IP address corresponding to that record would be a mail server, like a Hotmail server, okay, something like that. And then you have pointer records, PTR records. Is used to map an IP address to its corresponding domain name. Domain name. Okay, like so there is different. Now host name is different and domain name is different. Now it may look same, like how do I say that? So if I say google.com, now is that google.com a name of a single computer or a name of a group?
Which one, sir?
Google.com. Is that a name of a group or a name of a single computer?
Name of the company.
I gave you only two choices. Google is the name of the company. Google.com.
As the domain.
Yeah, it's a domain name. So domain, what do you mean by domain? Domain means a group. The synonymous of domain is group. So it's a group name. Like your WhatsApp group has a name, right? So that's a group name. And every single host, there are many computers part of the host. Now if you see this computer's name is BTR3-demo. This is host name. And it comes under the domain aptech.dh or aptech.dh.com. Okay, so this is the group name. So you can also convert an IP address to a domain name. That is, your group can also have an IP address. A single computer can also have an IP address. So a record is an IP address corresponding to a single host name. It points to a single computer. Whereas a domain name, a PTR record points to a domain, a group. Now in that group, it can be any other computer, any computer. Okay. So if it is pointing to a group, it's PTR. If it is pointing to a single host, single computer, it's a record. And these are the different types of records. And then you have SOA, start of authority, used to specify the DNS server which will provide, means this DNS servers can be is arranged in a hierarchical order. Okay, you have if your computer is you are putting a name on the computer, it needs to resolve. First, it will contact one DNS server, and if that cannot resolve it, that in its database it doesn't have the IP address, then it will contact the other level and the other level. So one DNS server has to point to another DNS server. For that you have SAO record to point to another host, which are DNS servers. And then you have COD. This is 4 A's or COD A. It is basically IPv6. The same as A record, but it's pointing to an IPv6 address, not IPv4 address. Every client can have an IPv6 address also. Okay, these are the different types of records you will find on the DNS server. Okay, but to keep it simple, a DNS server is name versus IP address. You give a name, it gives an IP address. Now IP address of what? That's what these categories. Okay. Now how do you do these DNS servers that we will see in the practical parts? Okay, that doesn't come here. Here we are just seeing the theory. Like you can make a Windows computer as a DNS server, DHCP server, or a Cisco device, or anything you can make DNS or DHCP. So how we configure it, how we change the settings, that I think we will do it a little bit in Windows Server also, and in CCNA also. So these DNS are normally dynamic. Okay, dynamic. Now let's say, for example, this is my computer, right? My computer name is BTR3-demo. So if I go and check your DNS server here, I think in our case this DS or Aptech.dh is the DNS server. So we have our gateway, not our gateway, our server is the DNS server. So if I go and check in my server, I will have a record called BTR3-demo, and correspondingly I will have an IP address, whatever IP address I have now. Okay. So if someone is doing /BTR3-demo, inside the switches, the IP address will be the IP address corresponding to the one on the DNS server. because the switches, they won't use the names, right? The switches will try to resolve the name, so they will find a DNS server, they will try to resolve the name to IP address. That's how. Now what if I shut down this computer and tomorrow I come back and I rust and I get a new IP address? Then that information has to be updated on the DNS server. So or maybe I change the name. Okay, so at this point some other person is having that IP address. So that is dynamic DNS. So whenever there is a change in the network, so every now and then the DNS server will check. It will send some pings and check whether it's still available or is it the same MAC address. Okay, so that way it will make sure that this DNS is always up to date. Okay, otherwise it will simply go to the wrong clients, isn't it? It's called DNS poisoning. Now you can do it intentionally also. Let's do a simple example here. So this is very basic, very simple and basic services. It's not complicated. Okay. You don't have to know the working at all. Maybe I think when you do a name resolution, let's say for example, if I take google.com. Okay. Now who knows the IP address of google.com? Ultimately, it's registered in the public DNS on the internet. But before that, your ISP knows. Before that, your gateway knows. Your firewall knows. Before that, your internal server, DNS server knows. And before that, your computer itself knows. So your computer will have a cache, DNS cache. Okay, if it couldn't find in that, then it will go to the next your DNS server. Then it goes to your gateway. Then it goes to your ISP. And finally it goes to the public DNS. Okay. So you have a cache in your local computer also. So it's not like every time it will be contacted to the public DNS. It can be retrieved from the local cache. And that local cache is somewhere in C drive window somewhere. It's hidden actually. C drive. Called drivers. Let's find out. You can search online. Regarding the DNS cache, there is a file. That's where the cache is. And if you corrupt the cache, it can point to wrong websites. Have a file called host. 2, etc. So the drivers, etc. host, and this is the cache. And with Notepad, see, if you open with Notepad, you will find this thing. You got the file? You open with Notepad.
Yeah.
So right now there is nothing in it, means that there are no records. It's not like there is no cache. I think cache is different, but you can use this one to point something else. So right now, see, hash or comments on. That's it. Let me ping. CNN. So this is the IP address of CNN. So I take this IP and I'm going to put a fake record saying this IP corresponds to some format. This IP corresponds to there's a permission. We don't have permission. It's saved in the desktop. From the desktop and cut it. I replaced it. But this is host.txt. Okay, somehow I just added that record. And then clear the browsing histories. Browser also action cache. Okay, so let me try Google.com. I don't know, I think this basic domain has added to a service. Something's happened. See, I think I did not add this properly. It's not going to Google, but maybe it's not the right IP for CNN. Maybe they use different IPs. This may be a gateway IP or something like that. We go for some other site. This has a straight IP. Aptech.com. It has a straight IP. So I put the IP of Aptech. IP. Maybe I think it's because we have this HTTPS, that's why. And then we don't have this HTTPS certificate to that whatever server we are pointing to. What if I do the other way around? If I take aptech.com, it should go to Google. You can do that one, right? So this is our local Google's IP. I put this IP to Aptech.com. So if I go and put Aptech.com, you see the same thing. It's working, but it's not. It's doing some checking. Actually, it has become more smarter now. It was not found on this other. So if I remove it, it's supposed to work. If I remove this thing, or if I just put it to comment it. Works, right? Just put this one back. It may take some time to update sometimes. But anyway, that's how you can change the DNS record, but this method doesn't work now. Because it's checking other parameters. Yeah, you see it's going to Google if I type aptech.com. But that IP is not actually the IP address of the web page of Google. It may be the firewall's IP address or gateway's IP address. So the ping is not giving the exact web page IP or web server's IP address. So that's why it's going to Google, but you're not getting the Google's page. You have to find the page, web server's IP. DNS. You just poison the DNS records. That's a hacking method. So you give a website address,
Mm.
you get the website, but that website is not really the website, it's a different website.
Yeah.
What if I make my own Aptech, I copied the aptech.com content, made my own aptech.com and I pointed to that aptech.com. So everything will be same, right? So this is where the digital certificates, all these things come in hand.
The only thing, sir, it's not a secure website.
Yeah, it's not secure.
It's not
website.
HTTPS.
You can play with the port numbers, protocols, and
First name. Nine.
Dito siya.
Yun lang ang chance.
Mag-give.